Hello student and welcome to the Python class. Here in this video we will be discussing about the data type in the Python, and here we go. So student, here we are going to learn about data type used in Python. So the core data type that we use Pythons have different form like number, none, sequences and mapping. None means absence of the value. When you don't supply any value, that is also one type of data, and that we call none. So if we talk about the numbers, so numbers are again divided into different subtypes: integer, floating point and complex number. And integer is also has one more subtype, that is a boolean. So here if we talk about sequences, so we will learn about the string, tuple and list, and mapping there is one data type, that is dictionary. So here in this video we will be learning these data type in some more details. So firstly we are going to cover this one, integer, these numbers. Okay, so here under number we have seen it's integer, floating and complex, and one more boolean is under integer only. So we are going to learn about integer, floating points and complex numbers. So first we talk about the integers. The two types, one is called integer signed. Integer signed means you could see these are the real number. Somewhere it's a minus, this is a plus. If there is no sign before them, we consider them as a plus. So we can say the real number or the integer type of number with their signs. And then comes the boolean. Boolean has two values, one is true and one is false. True is represented by 1 and false is represented by 0. So these are the two type of integer. One is integer signed and one is boolean. Boolean is also taken under integer only. Next we are going to learn about the floating point number. So these are the real numbers with the floating points. You could see here point, okay, 2.0 minus 3.45, 0.49, etc. So these are the floating point number. And next comes your complex number. So complex number is written in the form of a plus b, j. Sometimes it's represented by I, even I, bi. Okay. So this we call the real part. A is called real part and bj is called the imaginary part. The a and b are the floats number. Okay. And this j is represented by minus under root minus 1. So this we call a real number. If that is in this form, it's called a complex number. So moving further, now we are coming to the sequences. None data type I already told you, that is the absence of any value is called none data type. Sequences, we have already learned three things were there in the sequences. Okay, the string was there, list was there, and tuple was there. So now we are going to learn sequences is a group of items with a deterministic ordering. The order in which we put them in is the order in which we get an item out of them. Means to say that if you have put something in certain order, let's say here, let's say 5, 7, 1, 2. So these we have put in order. So we will get them in this order only. So these we call sequences, whether it is a string, whether it is a list, whether it is a tuple. So a little bit difference is there that we are going to learn next. So we talk about the strings. So strings are the sequences of pure Unicode character. You know, every character that you see on the keyboard has been assigned one code that we call Unicode. So these characters in a machine language are represented by that Unicode. So any language in the world, any character of any language in the world has been given a code that we call Unicode character. A string can hold any type of non-characters, i.e. letters, number, and special character. I have already told you whatever you see in the keyboard. So whatever we press with the help of these keys, so these symbols or these special characters or these letter or numbers are represented by Unicode characters. So it could be a character or series of letter like this. You can see here is a single letter, here's a series of letters, and here these are some special characters. So these all are stored or these all are manipulated using the Unicode characters. So these are the string. These are considered they are put in a codes, single or double quote, sometimes maybe triple quotes. So these we call the string type of data. And next we are going to learn about list. So a list in Python represent a group of comma separated values of any data type between square brackets. So the value is a series. You can see here example. So within the square brackets 3, 4, 6, 7, 29. Okay, here is a series of you could say strings A, B, C, comma are there, and they are put in a quote. Here's a mix. You can see one letter, and it's a group of letters. Here is the number. So anything you can put inside it as a series. So this we call list within the square bracket. Now we are going to learn about tuple. So tuples are represented as a group of comma separated values of any data type within parentheses. So that here lists were put in a square bracket, but the tuples are put in a parenthesis. Okay. So this is these are the example. So 2, 3, 4, but here is a parenthesis that we call small brackets. So B is equal to A, B, C, these are mixed data type. So these we call tuples. So list tuples. So first was your string, second was your list, third is your tuple under the sequences. Now next we are moving to the mappings. So mappings, only one data type was there, dictionary, and these are also series. Okay, comma separated series. Okay, so but it is a little bit different from tuple and list. So the dictionary is an unordered set of comma separated keys value. This is important here. Keys values means there would be one key colon and the value will be given there. So these are key value pair within curly brackets or curly braces in which the keys are unique value. Keys are unique values means here we'll see the example, not complete one. Okay, here should be curly braces are not here. So this is key 1 is a key and here's a colon and this we call value. So the value, the key for the value apple is 1. Then comma, this is the second key and the value assigned to this key is orange. And this is the third key and the value assigned to this key is banana. So these 1, 2, 3 are keys and apple, orange and bananas are values. Apple, orange, banana can be repeated, but this 1, 2, 3 cannot be repeated. It should be unique, means no other such key as you have already given cannot be repeated in the dictionary. So that's why it's called unique. It's in which the keys are unique values. Means 1, 2, 3, or likewise the keys will be the unique one. No other key will be repeated in the dictionary. For example, I have created this dictionary, and if I want the output from this dictionary, so let's say I want to print apple, so I will the name of the dictionary is fruit. I will write down here fruit, and within the bracket A is written there, and this apple will be the output. So these are the mappings. So you have a little bit idea about the integer, data type, string, and this all. We will just see a little bit about how do we create a list, tuple, and dictionaries, and how do we get output using the interactive mode of Python. So here I am going to create a list numb. So num is equal to 4, 6, 7, 8, 9. Okay, so this is creator. I'll print num here. So 4, 6, 7, 8, 9. Whatever is here. If I want to print, let's say, the value, the item at index 1. So I will just write down num1, and the 6 is printed here. Here is our list, and we have created in the list 4, 5, 6, 4, 6, 7, 8, 9. So this we call indexing, means each cell of the list has been given indexing. It will start from left to right, it is 0, it will begin with the 0, 1, 2, 3, 4. And from right to left it is indexing from -1, -2, -3, -4, -5. So likewise, so 0 and -5 is representing the same number. Likewise 1 and -4 like this represent the same number. So this we call indexing. And now I'm going to create a tuple. Let's say tuple, let's say vowels. So is equal to it will start with a small bracket. So A, B, A, E, A, I, A, E, I, O, U. So these are the vowels I've created. Now if I print this vowels, so this is created here, and if I want to print, let's say this one. So this is -1. I can just write down here -1 or 0, 1, 2, 3, 4. If I write vowels 4, so it will print U. If I write vowels -5, sorry, -1, so it will print the same value U. Now we'll create dictionary. Let's say I just want to create the details of the student according to their roll number. So 1 is assigned to, let's say, Mahima. 2, roll number 2 is given to, let's say, Ramesh. Roll number 3 is given to, let's say, Ria. Likewise, roll number 4 is assigned to, let's say, Nina. Okay, so it's closed, and now we print details. So all numbers are there. If I want to see the who is at roll number 3, so I will just write down details, and within the square bracket I will write down 3, and the student at roll number 3 will be printed. So I have just printed this key here, and the value that was assigned to that key has been printed here. So here it's a little bit different from list and tuples. There the values can be retrieved using the index number, but here the values are retrieved using the keys, which are the unique values. Now we will learn about mutable and immutable data types. So first is the immutable data. So data that can never change their value in place is called immutable data. Means the value that is stored in one place in one memory location cannot be changed. The variable names are stored as references to the value object. We will just see here with the example. We have already learned in the first video also. So suppose we have given this. We have assigned A is equal to 5, B is equal to 5, and C is equal to 5. So that means these A, B, and C are not different memory location. Okay, so they are indicating or they are referencing only the same memory location. You could see the ID of 5 is, let's say, this. So they are still, 3 of them are referencing to the same. It's not the 5 is stored in 3 locations. The 5 is stored in one location, memory location only, and all these labels, variable that you call. So these all the labels are referencing to the same memory location whose ID is this. Now if we change this, A is equal to 6, B is equal to 7, and C is equal to 8. So now we will see that A is referencing this, B is referencing this, and C is referencing this. They are not referencing now this the same memory location as they were doing earlier. No, they are now referencing the different memory location. So this we call that immutable. We cannot change this memory location, cannot be changed. Means the 5 will remain there only. If we change the value of variable, they will start referencing the other memory locations. So here we will learn about the immutable data. So here I have assigned A, B, C, all the 3 variables have been assigned with the 5. Now if I type the ID of A, so it's this. If I type ID of, let's say, B, it's this. And if I type ID of C, so it's this. So you could see here that all the IDs of ABC are same, means ABC are locating to the same ID, locating the same memory locations. So that means where the number 5 is storing, these ABC are only referencing that memory location. Now if I want to change the value of B, let's say B is equal to, let's say I just want it to be 10. Okay, so initially the B was assigned with 5 and the ID of B was this 14554869660. Now I have assigned another value to B and I just want to check the ID of B. So ID of B, now you could see it stands now. That means we cannot change the value in place, means we cannot change the ID of the number where 5, ID of the memory location, we cannot change the value in the ID where 5 was stored. 5 was stored in this one and that was referenced by A, B and C, all the variables. I wanted to change the value that was assigned to B is equal to 10. So here I printed again the ID of B, so the ID has been changed. That means now B is referencing other memory location. We couldn't change the value that was stored in this ID, and that value was 5. We couldn't change that 10 to be stored in this ID. So 10, the B is referencing 10, but this is not the same memory location as B was referencing earlier. So it's now referencing to this. So this, if again C, I just want to change the value of C, and I will just see the ID of C. So here it is also changed. Initially ID of C was this. Now ID of C has been changed here. Type. So data type whose value can be changed in value or in place. It should be in place. Whose value can be changed in place. So it's a place P A C E. Okay. So that is called mutable. So some values are mutable. Some data types are mutable in Python. So like list, dictionary and sets are mutable, means you can change the value of the same ID, same memory location. For example, I have created one list here, marks with 5, 6, 7, 8, and next I said marks 1 means index 1 at index 1. So 6 is index 1, this one. So I want 30 to be stored there. So if I display the item in marks next time, so it will initially the 5, 6, 7, 8. Now it will show 5, 30, 7, 8, and ID will be same. We will just see it. So here now we will learn about mutable data. Mutable data means the value that can be changed in the place. Means ID will remain same, but we can change the value. So there are certain data type like list, number, so tuples. These data type are mutable. Now I just want to display here num. So these are the value. Next time I just want to change some value there. Let's say I want to change the value as index 1. So index 1, right now at index 1 the value 4 is there, but I want it to be, let's say, 50. Okay. Now I just want, before that I just want to see the ID of num. Okay. So this is the ID. Now I just want to change one more value there. Let's say index 2 is equal to 60. Okay. So now you can see, we will just display the values in num. You could see here initially it was 3, 4, 5, 6. Now it's a 3, 50, 60 and 6. Now we will see the ID of num. You could see ID same 58449992, 58449992. The ID is same, whereas we were able to change the value of these two indexes. We can change even though, okay, these and this. So these we call mutable data type. That means the value in place has been changed. ID is same, in place means the same ID. The same ID we have changed the value. Initially it was 3, 4, 5, 6. Now it's a 3, 50, 60 and 6. Now we are going to learn about the different type of expressions. So expressions are the combination of operator, literal and variables. So arithmetic expression, where you will see the arithmetic operators are involved and the operands. These are the relational expression, where the relational operators are there. Logical expression, where the logical operators are there. And string expression, where strings are manipulated. Here Ajit plus Singh will give Ajit Singh here, and this apple into 3 will print apple 3 tab. So these are the different type of expression. We're talking about the type conversion. So to understand this, I've just written one expression here, 5 minus 4. So you know that this 5 and 4 are operand, and this minus is called operator. This is operator. Now if we see this expression here, 4 plus 8 will get computed, and the result will be stored here. Now if we see at the data type, so data type are integer type. So both the integer, when they get added, they will store in A, and definitely the resultant data type will be integer. Here is a floating point, and when they get added, they will be stored here A, and the resultant data type will be floating type. So there is no doubt. But here, if you see, here is a floating type, and this is a integer data type. Now the question arises that what will be the resultant data type when the two operand, one is in floating type, another is a integer type, or maybe the different operands. When different operands I get evaluated, so what will be the resultant data type? That is what we are going to learn here. Okay, so the rule is that if in the expression either number is complex, this is a complex number. If either number is a complex, another maybe, let's say, integer type or floating type, so the data type will be complex one. Next, if complex number is not there but floating number is there in the expression, so the resultant data type will be floating point. Yes. Okay. And if both are the integer type of data, so definitely the resultant type will be integer. So either number is complex, so data type will be complex. If either number is float points, so resultant type will be float point. And if all the numbers are integer, so it will be integer type of data only. Okay, now we are going to see some examples. So here we can see that 8 is divided by 4. Both are integer. So as we have discussed earlier, that if the two operand are integer, so the resultant data type will be integer. But this operator is exceptional. This operator always give you float type of data. Int is divided, this is a division operator. So int is divided by int, so this will always give you floating type of number. This is modulus operator. So if a float number is divided by an integer, so it will give float number only, and this is your Floor division. So if one int is divided by this Floor division, using the Floor division, so it will give you integer type. So the main is thing integer and integer, but this will give you float type. We'll just see it. So okay, we are going to divide, let's say 8 divided by, let's say, 4. So both are integer type of data. So here you could see the result is a float point. Okay, and if we use, let's say, 6.8, and we are using the modulus operator and divided by, let's say, 2. So this is float point, and using modular divided by integer. So here it is a plot point. Now next, if I am going to divide, let's say 6.8 and using this divided by 3. So this is a division type. But if I am going to divide, here one was float point and this was integer, it's giving you float point only. And if I divided by this 8 divided 8 divided by 3. Okay, so this is integer and this is also integer. So in general, the result should have come in a float point, but here you will see that it is a integer type of. So integer with a float division, it will give you integer only. So this is we have. Now we will see some more example of type conversion. So here is a is equal to 5 and b is equal to 6. Now I just want to create one complex number, c complex a comma b. Now here c is a complex number. Okay, if I print c, so here we print c. So 5 plus 6 is a complex number. Okay, and even if you want to see the type of this c, so you will see it's a complex number. So I just want to add b, and let's say d is equal to c plus. So this is a complex number. I just want to add one float number here. So what is c? The complex number. What is this? A float number. If these two type of number are added, we will see what will be the resultant data. Resultant data type that is stored in D. So it's done. Now we will see the type of D. So let's say print D. So you could see it's a complex number. So we have learned that either number is complex, so resultant data type will be complex. Here C was complex, this was a float, so the data type was complex only. Next example, we will just see, let's say Z is equal to one number will have 7.8 and one we are going to have integer type of data. So it's a complex and it's an integer data type. So what will the resultant data type? We will set print z and you can see it's a float point. Okay, so this is we can see. So if both are let's say data type, both are integer type 5 plus 6, so of course it's a integer type only. Now we will learn about explicit type conversion. So here I just want let's say a is equal to 6 and b is equal to let's say 7.8, and you know if I add a and b, c is equal to a plus b, so the resultant data type is going to be float type. This we have already learned. Okay, one is integer, one is float, so resultant data type is going to be float. But if I want it to be integer type only, so here I can intervene. You can say that the programmer can intervene here. So I will just write down here int b. You will see now I will print c. So here is 13. Now it's a 13. No, it's not. No more floating type of data. So this we call explicit type conversion. So that is all for today. Thank you very much.